I guess to start off with, and I might be revisiting some territory that some of the earlier speakers have covered, but I thought it would be worthwhile just to revisit, why we're here. Why are we having a conference about AI and cyber? Why are we having it now? Because, AI has been around for a long time, but the reason that there is so much interest in it and the reason that it is now becoming much more accessible to small and medium-sized enterprises has to do a lot with improvements in computer processing power and a lot of the advances in technology that we've made very recently. So it's not really that long ago that the world's first computer was developed back in 1946. And as you can see, it weighs 30 tons and we have far more computer processing power in our pockets or in our handbags in the form of our mobile phones than was ever accessible by that first computer. So what that has meant is that we're finally able to put a lot of applications like artificial intelligence to much better use nowadays than we were able to do in the past. And a really good example of this is how we are currently applying computer vision to many problems. So it wasn't that long ago that if you were to put a camera, which is effectively a sensor, on a machine like a robot and then tried to get the robot to make a decision about what it was supposed to do, that it actually wouldn't work very well, because by the time the camera had collected the information and the machine had processed all of that rich visual information and really analysed the scene and worked out where the robot could travel, whether there was something in its path or not, or what it was intended to do, a few hours or even a few days may have gone past because we didn't have the computer processing power necessary to be able to process all of that information. But nowadays we can put a camera on a small robot, as in this example, and actually get it to do things in real time. And what that means is it really has opened up a whole range of things and activities that we can now do that we weren't able to do in the past. And that, in many cases allows us to take people out of dangerous situations. In this case, the robot is using the camera to take a photo of a line, which is clearly, maybe much closer to the line than we might want to send a human in to do the same task. So it has really only been possible to do that in the last few years. And so this has really opened up a whole range of applications for artificial intelligence that were not able to really be fully utilised in the past. So that's why the time is really now for the application of artificial intelligence. And another thing that has had a big impact has been, the introduction of machine learning and the transfer of really knowledge-intensive tasks and functions in business processes over to computer systems. Now, in the past, this used to involve a lot of codification. So, for example, if you wanted to tell a robot to do something in a business operation, then you would have to explain in explicit language, line by line, in code, what the robot needed to do, what it would do in case a circumstance changed, if then what. And nowadays, and in particular since the advent of deep learning 7 or 8 years ago, we can even take that further. So not only do we not have to explicitly code to get machines to do things for us, we can even get those machines to learn by example. So in this case, a human is actually illustrating a task to the machine, and the machine is learning by example. This opens up a range of possibilities. We're now getting to the point that machines, a bit like our teenagers, learn a lot of what they know by watching YouTube videos. And this takes away a lot of the burden of having to really dissect and analyse every task that we might want to do in a business and figure out how to turn that into code, because we can apply machine learning and in particular techniques like deep learning to understand that task and to be able to get the machine to follow that and actually carry out that task. So how can artificial intelligence benefit small to medium-sized enterprises? And again, I'm probably going over some territory that's already been covered by previous speakers, but really the big benefit is that AI systems can detect patterns in enormous volumes of data, and they can model complex interdependent systems to help improve decision-making and cost efficiency. AI can be used to help better utilise equipment and processes, and can be used to help address labour shortages by automating some particular tasks in businesses. AI can also be used to help make workplaces safer by identifying and even predicting areas which may become potential hazards. So you could actually probably expand this list threefold. There are a number of advantages of artificial intelligence, but in parallel, there are a number of barriers and challenges, which I'm sure many of you are aware of. The first of these is that building and maintaining an AI system is a costly investment. And so that's why, I guess, to date, a lot of the implementation of artificial intelligence that we have seen has been limited to larger corporations who can accept the sunk costs that are involved. So it also can involve adapting business processes and might require skills that aren't necessarily available in the workplace. The large amounts of data that are used in developing a lot of AI solutions can also open up some reputational and legal risks. And I think, as probably has been covered in earlier sessions about cybersecurity, making sure that organisations can identify and protect against data breaches is becoming increasingly important. I think another real problem is that you can develop the most sophisticated and useful AI system in the world, and it will never succeed if the people in the business are not prepared to use it. And I think this resistance, and sometimes that can actually equate to a lack of skills and confidence in artificial intelligence, is again a real barrier that needs to be addressed before you can successfully implement an AI system. And I think it's also fair to say that for a lot of small to medium-sized enterprise, there's actually a lack of data, or while data might exist in the business, it's not really in a format that actually lends itself for use in AI systems. So a lot of back-end work has to be done to collect the data and make it ready. Having said that, there are a lot of sectors that are seeing companies adopting artificial intelligence and digital twins. A survey that the Queensland government put out reasonably recently suggested that the sectors that are most likely to be adopting artificial intelligence include defence leading the way, mining and energy, agriculture, forestry and fisheries, manufacturing, healthcare and transport. Now, interestingly, financial services don't appear in this particular survey, but arguably it is the most advanced in many forms of the application of artificial intelligence. Now, in terms of digital twins, just to give a bit of background, a digital twin is an identical virtual representation of real-world physical objects, such as a piece of machinery or even an entire plant and all of its equipment. So it can be used to predict behaviour under a variety of conditions without you having to physically do those tests. This can help drive improvements in process. The other advantage of having a digital copy of your plant or equipment is that you can do very effective and efficient predictive maintenance. In some cases, this can mean that you actually don't need to have somebody on site to check whether something is working. You can be able to do that remotely and then determine whether you need to send personnel in to deal with an issue. And I guess the other really useful thing, and I think sometimes underappreciated advantage of adopting digital twins, is that it can help you develop new products based on actual usage patterns of existing products. It all depends on how much data you're actually able to load your digital twin up that's relevant to your business. So as I mentioned, you can use digital twins to model the whole process, in this case, a manufacturing process. This is a diagram from Dassault where they have a digital twin of a production line. This starts as a 3D digital model developed by computer-aided design or generative design, and you add additional layers of data to the model from simulation and also from real-world testing, coupled with any manufacturing data that you might have, so you can help to flesh out your digital twin. Now, if you don't have data, you don't have to worry too much. It's actually not that hard to get. I'm giving you a bit of a virtual tour of my home, the Queensland AI Hub, located in the precinct in Fortitude Valley in Brisbane. Now, this data set was collected by Stefan Haber, who is the CEO of Emerson, who walked around with a handheld laser scanning device and in 5 minutes was able to collect enough data to construct essentially a digital twin of our workspace. If we were to put more effort into this, we could actually apply measurement data, look at the exact placement of all of the items in the space, do some volumetric analysis. But really, you need something like this as the starting point for creating a digital twin. And that doesn't necessarily need to be a complicated process. As I mentioned, this was a 5-minute scan with a handheld laser scanning device. You can also, rather than looking at the entire operation, you might just concentrate on one particular piece of equipment or a physical asset. This can be very useful in terms of the amount of data that you might have that you can associate with a particular piece of equipment. And if it's a vital piece of equipment, this can be extremely useful for preventative maintenance, so that you're keeping an eye on all of the data that's coming off that in the digital twin in real time, so you can assess whether there is a potential problem coming up and then take measures to help that. It can help you assess the product's performance over time. Really, any data that you have related to a piece of equipment can be inserted into a digital twin. Just to start giving you a few examples of this is a local manufacturer that's applying digital twins in its automatic fibre placement process. The advantage of using the digital twin has meant that they're able to simulate how that fabrication process should be most effectively done, and it has allowed them to predict where defects are likely to occur. Now, the way that this was done in the past, before they used digital twinning, was that they would use physics modelling. What they found was that physics models were able to detect about 35% of the defects that were inherent in the fabrication process. But now, since they've applied digital twins, they are able to detect defects at a 98% success rate. So not only have they found the AI has been useful in detecting defects and then allowing them to change their process to reduce those number of defects, they've also found that it's helped them inform them how to inject and cook their composite materials. And by doing this, they've seen a 60% improvement in cycle time and performance of the product during the curing process. So, you can see there's a lot of value if you have a digital twin of a particular process in being able to optimize that process and get the best value out of it, which can have direct improvements in efficiency and then profitability of the business. Another example where you can apply digital twins in additive manufacturing is in the 3D printing of metal components. So there are a number of complex factors at play that lead to complexity in the form and the material properties and integrity of metal components when you manufacture them by 3D printing. So these can be related to a huge number of factors like laser power, the laser speed, the spot size, the pass overlap, powder composition, whether there are any contaminants. All of this can lead to porosity in the finished product and potential defects. And I guess that's one of the things that's holding some of these processes back in terms of being able to guarantee high quality, replicable processes so that each part can meet quality standards. But now, thanks to artificial intelligence, if you are to do a digital twin of this process, what it means is that in real time, the laser can be adjusted while it's forming the 3D metal parts to reduce the number of defects. So the same manufacturer that I illustrated using artificial digital twins for the composite fabrication is also using this for their metal 3D printing as well. And while they're fairly new at this process, they are noticing that it's able to reduce the number of defects and help to produce consistent high quality parts. Now, I thought I'd give a couple of other examples that since we've been going out into the different regions in Queensland, we've found some interesting use cases of digital twins, which might be relevant to some SMEs. One of them is with a plantation company that operates in central Queensland. So they are currently flying drones through their plantation to collect enough data to produce digital twins. And they're able to then use this data to, calculate, the volume of material that they have in their plantation. But importantly, what it has meant for them is that one of the ways that they can make sure that they're getting the highest quality timber is that they will selectively choose trees that they will prune. And then 20 years down the track, they want to be able to selectively log that timber. However, one of the issues that they face is that often in these quite remote and inaccessible areas, by the time they go to log this timber out, what has happened is that lantana has covered the entire area, and it's not necessarily easy for them to identify which trees they need to preferentially log the high value timber. By using digital twins now, they know exactly where every tree is. So they can have GPS coordinates that locate the exact position of the tree that has undergone pruning so that they can send in people to preferentially log those trees and send them to the exact location. And I guess there's no end to the potential applications that they are going to find for this, but this is their first use case. Another interesting application is in agriculture. This is a company called Green Atlas Cartographer that runs up and down fruit orchards and is collecting data on the trees and essentially creating a digital twin of these orchards to give information to the farmer that can help in the assessment of when those trees need to be maintained, and also when is the best time for harvest. And this is the sort of data that they're getting. These are fruit trees. What they're collecting is information about the fruit and flowers on each of the vines, and essentially constructing a digital twin of the farming environment to help optimize the decision-making process. Another interesting area that we discovered when we were out at Rockhampton, we were introduced to a technology that had been developed up there, which is now being applied in a range of different areas, which was around analysing biomass, and had been applied, first of all, to look at how to preserve the barramundi stocks in the Fitzroy River near Rockhampton. And the way that they did this was by using echo sounders to actually look at what size of fish, what type of fish, and also what vegetation, what other natural organisms were in the river. So essentially they were creating a digital twin of the river. You can also recreate this process in the ocean as well, so that you can get a really good sense of what are the fish species, how mature they are, which areas of the ocean they're occupying, and give real-time feedback to our trawlers on which fish they're allowed to take from the ocean and which fish they should be sending back in because there are low fish stocks. And this now has been pushed to the point where consumers can essentially use an app on their phone so that you can actually track your seafood directly from where it has been caught to where you're picking it up in the market. So you know the exact time that it's been taken out of the ocean and the exact location from where your seafood has come. So I think that's another really interesting application of digital twins. And yeah, this is just to give you an example of the type of information that's being collected in terms of counting the numbers of fish, the sizes of fish, the type of fish. All of this is available now, and when combined with and put into a digital twin, can give a real-time assessment of the health of some of these ecosystems. So there's a range of different ways that you can apply digital twins, and many of these are accessible to small and medium-sized enterprises. And I think then the next important thing to consider is how you can prepare your business for artificial intelligence. And the number one priority really needs to be around workforce planning. As you probably would have gathered from all of the presentations today, a different type of skill set might be required to really be able to apply artificial intelligence, and actually working out what those skill sets are, doing a whole lot of skills mapping to work out what in the future the skills of your business is going to require. Is important so that you can then start looking at how you might reskill some of your existing staff to meet gaps that you've discovered. It's important when thinking about AI to be looking at tasks rather than jobs. You might find that AI is replacing some parts of people's jobs. It's unlikely that it will replace a whole job. But that's where, again, going back and having a look at your workforce planning, what skills you need to run the business, what tasks you can automate versus what tasks will always need a human to do, is an assessment that needs to be made. The other important thing that goes hand in hand with having a look at your skills is actually about how you can foster new ways of leadership thinking. If there's not buy-in from the top of the organisation in AI transformation, then it's unlikely to happen. So not only does the leadership of the organisation need to be on board with adopting artificial intelligence into the business, but it also might require some rethinking of business models, because the real advantage of applying artificial intelligence is that you might find new products and services that your business can be offering that will make it far more profitable. And I guess the business has to be flexible enough to be able to adopt and make use of all of the new information that's going to be coming back into the business. And another big advantage of applying AI is that it does allow this ability to respond very quickly to customer feedback. And again, that could mean a change in the way that the business operates to enable it to be agile enough to be responsive to customer feedback and to give people the customization and the personalized attention that they probably require and will increasingly demand as other companies become AI enabled. So that's just a quick snapshot of some ways that you might consider applying artificial intelligence in your business and how it can improve business processes. Thank you very much.
Thank you very much. Thank you very much, Sue, for a fascinating insight and a snapshot of how AI is being used in Australian industry. I just have a quick question. So the examples of digital twins that were shown here look like more larger scale operations like factories and farms. For a small business, is there a price point and sort of static in nature, so it doesn't change all the time? So for a smaller business, is there a price point where having a digital twin, if you're writing a business case for a digital twin, is there a price point, or how would you make a decision whether a digital twin is beneficial or not? Or is it a bit of cost versus what the benefits can bring in the future type of thing?
If you have a business that requires lots of customization and where it is difficult to actually map out your processes, then it is probably likely to be a business that is not going to see as much benefit out of digital twins today as businesses such as in manufacturing, where they usually have fairly well understood processes and are reliant on equipment to be able to do what they have. Digital twins may not be as useful, but other forms of artificial intelligence might be useful. For example, and I don't really know how much our banks do use digital twins, but I would imagine that's not as useful for them as it would be for a company that has physical assets. So probably companies that have physical assets would be the ones that would be looking for digital twins first, but other companies can certainly benefit from artificial intelligence, but it might not necessarily be digital twins.